There is a wall at the edge of time, a literal barrier beyond which no telescope has ever seen, until now. And what scientists found on the other side is rewriting everything we thought we knew about how the universe began. We are living through one of the most extraordinary moments in the history of astronomy. Right now, orbiting nearly 1,000,000 miles from Earth, a golden machine the size of a tennis court is staring back into a time before stars existed, before galaxies, before light itself had anywhere to go. This is the story of cosmic dawn, the moment the universe switched on, and the remarkable race to witness it. But here is the question that should keep you up at night. If the universe started in a blaze of energy with the Big Bang, why did it then go completely dark for hundreds of millions of years? What happened during that cosmic blackout, and how do we even begin to look for light that ancient? Hold on to that, because the answer is stranger than almost anyone expected. To understand what we're chasing, we need to go back, not just back in history, back in time itself. The Big Bang happened roughly 13.8 billion years ago. In the first fraction of a second, the universe was a furnace, unimaginably hot, impossibly dense. Then it expanded, it cooled, and about 380,000 years after the Big Bang, something remarkable happened. The fog cleared. Protons and electrons combined to form the first hydrogen atoms, and for the first time, light could travel freely through space. Cosmologists call this moment recombination, and we can actually see it. It's the cosmic microwave background, a faint glow of ancient light that fills the entire sky, the oldest photograph the universe has ever taken of itself. NASA's WMAP and Planck satellites mapped it in stunning detail, and it tells us the universe at that moment was almost perfectly smooth. Almost. Not quite. Now here's where it gets genuinely strange. After that first light was released, the universe went dark again. There were no stars yet, no galaxies, just an ocean of hydrogen gas, slowly drifting in the dark, pulled together by the invisible hand of gravity. Cosmologists call this era the Cosmic Dark Ages. For somewhere between 100 and 500 million years, the universe was essentially a lightless void. And then, something ignited. The first stars were nothing like our sun. They were monsters, hundreds, possibly thousands of times more massive, burning millions of times brighter, blazing with a blue-white ferocity that nothing in today's universe can match. Astronomers have given them a name, Population 3 stars. And here is the haunting part. We have never directly seen one, not a single one. They lived fast and died violently in supernova explosions so powerful they seeded the universe with the first heavy elements, carbon, oxygen, iron, the very atoms that would eventually become planets and people. But were they real? How do we know they existed at all?
That open question has driven some of the greatest minds in astrophysics for decades, and it's the reason the James Webb Space Telescope is the most important scientific instrument humanity has ever built. Webb doesn't just see farther than the Hubble Space Telescope, it sees differently. Hubble was primarily an optical telescope. It saw the universe roughly as our eyes do. Webb sees in infrared, which means it detects heat signatures, and crucially, light that has been stretched by the expansion of the universe over billions of years. The universe's expansion is like a cosmic redshift machine. Light that started out as ultraviolet or visible light 13 billion years ago has been stretched all the way into the infrared by the time it reaches us. Hubble couldn't see it. Webb can. And Webb has already delivered. In 2022, just months after going operational, it imaged galaxies so old they shouldn't have existed yet by our models. One candidate galaxy, designated JADE's GAS Z13-0, appears to date back to just 320 million years after the Big Bang. Another, announced in 2024, pushes even further, potentially forming a mere 200 million years after the universe began. These weren't just distant smudges, they were structured, star-forming, surprisingly massive. The discovery forced cosmologists to ask an uncomfortable question: does the standard model of galaxy formation need a serious revision? Some researchers think the answer is yes. Now here is the perspective shift, the moment that should change how you see the night sky forever. When you look at a star, you're not seeing it as it is, you're seeing it as it was, because light takes time to travel. The North Star is 433 light-years away, meaning you're seeing it as it looked during the Renaissance. The Andromeda Galaxy is 2.5 million light-years away. You're seeing it before humans walked the Earth. And when the James Webb Space Telescope looks at those faint, ancient galaxies near the edge of the observable universe, it is literally looking back in time to an era before our solar system existed, before Earth, before the atoms in your body had even been forged inside a star. The telescope is a time machine, and it is working. But we still haven't found population 3 stars directly. That remains the great white whale of observational cosmology. Webb is hunting for them. The signatures would be subtle, specific chemical fingerprints in the spectra of extremely distant galaxies, or perhaps the afterglow of an ancient gamma-ray burst from a dying first-generation star. Some researchers believe Webb may detect their indirect signatures within this decade. Others think we'll need the next generation of enormous ground-based telescopes, the extremely large telescope in Chile and the 30-meter telescope, to finally pin them down. Here's what makes all of this feel almost philosophical. The light we're chasing has been traveling for over 13 billion years to reach us.
It left its source before the Earth existed, before the Sun was born. It crossed the void of an expanding universe, dodging galaxy clusters, threading through cosmic filaments of dark matter. And it arrived, right here, right now, at a mirror coated in gold, drifting silently through space at Lagrange point 2. The universe has been sending us a message since almost the moment it began. We are only just now learning how to read it. Cosmic dawn isn't just a scientific milestone. It's a reminder that we are a species young enough to be awed and old enough to ask the right questions. Every image Webb sends back is not just data. It is a dispatch from the beginning of everything. And the most staggering discoveries, the ones that will rewrite the textbooks, are almost certainly still coming. If this journey to the edge of time sparked something in you, hit that like button and subscribe so you don't miss what comes next. And I want to know, what do you think the James Webb Telescope will find next? Drop it in the comments. Next time, we're going somewhere even stranger, inside the most violent event in the observable universe today.